20 AI algorithms and their Azure solutions. In the rapidly evolving landscape of artificial intelligence, various algorithms serve distinct purposes across industries. Here's a comprehensive guide to 20 AI algorithms, complete with descriptions, real-world examples, and relevant Azure solutions. 1. Naive Bayes description. Naive Bayes is a probabilistic classifier based on Bayes' theorem, assuming independence among features. It's particularly effective in text classification tasks. Live example. Email filtering systems classify incoming emails as spam or not spam based on historical data. Azure solution. Azure Machine Learning allows you to build and deploy naive Bayes models for spam detection efficiently. 2. Random forest description. Random forest is an ensemble learning method that constructs multiple decision trees to improve prediction accuracy and control overfitting. Live example. Financial institutions use random forest models to predict stock prices and market trends. Azure solution. Azure Machine Learning supports building and deploying random forest models for precise financial forecasting. 3. Logistic regression description. Logistic regression is used for binary classification tasks, predicting the probability of a binary outcome based on one or more predictor variables. Live example. E-commerce platforms utilize logistic regression to determine whether a customer will purchase a product. Azure solution. Azure Machine Learning can be used to implement logistic regression for effective marketing strategies. 4. Decision trees description. Decision trees are flowchart-like structures that use a tree-like model of decisions and their possible consequences. Live example. Businesses can predict customer churn by analyzing past behaviors and preferences. Azure solution. Azure Machine Learning offers tools to create decision tree models for customer relationship management. 5. Linear regression description. Linear regression models the relationship between a dependent variable and one or more independent variables, predicting outcomes based on historical data. Live example. Retail companies forecast sales based on trends and seasonal patterns. Azure solution. Azure Machine Learning provides capabilities for implementing linear regression for accurate sales forecasting. 6. K-nearest neighbors, KNN description. KNN is a non-parametric method used for classification and regression by measuring the distance to the nearest neighbors. Live example. E-commerce platforms use KNN to recommend products based on user preferences and purchase history. Azure solution. Azure Machine Learning can be utilized to create personalized recommendation systems using KNN. 7. Recurrent neural networks, RNN description. RNNs are designed for sequence prediction problems, capable of learning from sequential data and remembering previous inputs. Live example. Companies analyze customer feedback over time to identify trends in sentiment. Azure solution. Azure Machine Learning allows for the development of RNN models for sentiment analysis. 8. Ant colony optimization description. This algorithm is inspired by the foraging behavior of ants and is used for solving complex optimization problems. Live example. Logistics companies optimize delivery routes to minimize costs and improve efficiency. Azure solution. Azure functions can be employed to create custom solutions for route optimization. 9. Principal component analysis, PCA description. PCA is a dimensionality reduction technique that transforms high-dimensional data into a lower-dimensional space while preserving variance. Live example. Image processing applications use PCA to reduce file sizes for storage and transmission. Azure solution. Azure Machine Learning provides tools for implementing PCA in image processing tasks. 10. Gradient boosting description. Gradient boosting is an ensemble technique that builds models sequentially, each correcting errors made by previous models. Live example. Financial institutions use gradient boosting for credit scoring and risk assessment. Azure solution. Azure Machine Learning supports the implementation of gradient boosting for robust predictive models. 11. K-means clustering description. K-means is an unsupervised learning algorithm used for clustering data into distinct groups based on feature similarities. Live example. Companies segment their customers into different groups for targeted marketing campaigns. Azure solution. Azure Machine Learning allows for customer segmentation through K-means clustering. 12. Long short-term memory, LSTM description. LSTM is a type of recurrent neural network capable of learning long-term dependencies in sequence data. Live example. Retailers forecast product demand over time using historical sales data. Azure solution. Azure Machine Learning can be used to implement LSTM models for accurate time series predictions. 13. Natural language processing, NLP description. NLP enables machines to understand, interpret, and respond to human language in a valuable way. Live example. Chatbots enhance customer support by understanding and responding to user queries effectively. Azure solution. Azure Cognitive Services, specifically, the text analytics and language understanding services, can be leveraged to develop NLP-driven chatbots for efficient customer interaction. 14. Neural networks description. Neural networks are a set of algorithms modeled after the human brain, designed to recognize patterns and classify data. Live example. Security systems use neural networks for facial recognition, enhancing safety measures in sensitive environments. Azure solution. Azure Cognitive Services, Face API, provides advanced facial recognition capabilities, allowing businesses to implement secure access control systems. 15. Genetic algorithms description. Genetic algorithms are search heuristics that mimic the process of natural selection to find optimal solutions to complex problems. Live example. Logistics companies optimize routing and scheduling to improve delivery efficiency and reduce costs. Azure solution. Azure Machine Learning can be utilized to develop genetic algorithms for solving complex optimization problems in logistics. 16. Support Vector Machines, SVM description. SVM is a supervised learning model that analyzes data for classification and regression analysis, identifying the best hyperplane for separation. Live example. Handwriting recognition systems in banking utilize SVM to classify and digitize checks. Azure solution. Azure Machine Learning allows for the implementation of SVM models in handwriting and document classification tasks. 17. Reinforcement learning description. Reinforcement learning is a type of machine learning where an agent learns to make decisions by taking actions in an environment to maximize cumulative reward. Live example. Automated trading systems in finance leverage reinforcement learning to learn optimal trading strategies based on market conditions. Azure solution. Azure Machine Learning provides tools to develop reinforcement learning models for dynamic decision-making applications. 18. Gaussian Mixture Model, GMM description. GMM is a probabilistic model that assumes all data points are generated from a mixture of several Gaussian distributions, useful for clustering and density estimation. Live example. Network security systems use GMM to identify anomalies and detect potential security threats. Azure solution. Azure Machine Learning supports the implementation of GMM for anomaly detection in various applications. 19. Association Rule Learning description. Association rule learning is a rule-based machine learning method for discovering interesting relations between variables in large databases. Live example. Retailers use association rule learning to uncover patterns in customer purchases, enabling effective cross-selling strategies. Azure solution. Azure Machine Learning can be used to implement association rule learning for targeted retail analytics. 20. Word embeddings description. Word embeddings are a type of word representation that allows words to be represented as vectors in a continuous vector space, capturing semantic relationships. Live example. Search engines improve the relevance of search results by understanding the semantic meaning of queries. Azure solution. Azure Cognitive Services, Text Analytics, can enhance search algorithms by leveraging word embeddings for better semantic understanding. Conclusion. The integration of AI algorithms into business processes can significantly enhance efficiency, decision-making, and customer satisfaction. By leveraging Azure's robust cloud services, organizations can effectively implement these algorithms to meet their specific needs and drive innovation. Whether it's through predictive analytics, customer engagement, or operational optimization, the possibilities are vast and impactful in the digital